Hello everyone, welcome to our presentation on breast cancer detection using machine learning algorithms. Today we will discuss how machine learning can be used to classify breast cancer tumor as either malignant. Our group consists of Jamis Morodia, Paras Patel and Abdullah Faryad, and we will guide you through the project's key points. In the next slide, introduction and motivation. Breast cancer is one of the most common cancer affecting women worldwide. According to recent statistics, 1 into 8 women will be develop breast cancer in their lifetime. Early detection of breast cancer significantly improves the chances of survival. However, relying solely on human expertise can be sometimes lead to delay on incorrect diagnosis, particularly in the area where access to advanced medical technology is limited. This is where the machine learning can play a crucial role. By analyzing complex data patterns, machine learning models can assist the doctor in detecting breast cancer at an early stages. In our project, we aim to develop machine learning models that use tumor features data to accurately classify tumor as either malignant or benign, potentially reducing the human error and speeding up to diagnosis process. The motivation behind this project is to leverage this technology to support healthcare professionals, particularly in resources limited to settings. We hope that by the improving designation accuracy with the machine learning models, we can contribute more effective and accessible healthcare solutions. As shown in figure, 60% of the there is a three pillars: pillar 1, pillar 2 and 3. In pillar 1 there is a 60%, and then pillar 2 at the 60 days, and then 3 is 80%. In next slides, overview of machine learning. Let's talk briefly about machine learning and why it's a powerful tool in medical diagnosis. Machine learning is a subset of artificial intelligence that enables systems to learn from data without being explicitly programmed. It uses algorithms to analyze data, find patterns, and make decisions. In our case, machine learning helps in breast cancer detection by analyzing data from tumor features. These features could be including the size of tumor, its texture and its pattern. The model learns from the labeled dataset where we know whether the tumor is malignant and applies this knowledge to new unseen data to predict the tumor classification. There are different types of machine learning algorithms and each has strengths and weaknesses. The key advantage of machine learning is its ability to process large amount of data and find the patterns that might not be obvious to the human eyes. For example, in medical examining, the machine learning models can be detect subset variations of mammograms that could be indicate cancerous growth. Machine learning is used in many industries, but its role in healthcare is particularly programming. Algorithms can be trained to analyze the complex medical data, such as genetic information or clinical imaging data, and help with these tasks like detecting tumors, identifying disease patterns, and even predicting the patient outcomes. The machine learning is involving the algorithms and recognize pattern to make the prediction based on the input data. Here is showing there is a 7 types of machine learning parts: the machine learning, natural language processing, expert systems, speech recognition, vision, robotics, and planning. In next slide, type of machine learning algorithms. Now let's look at the different types of machine learning algorithms which are centered to how we approach this project. We use supervised learning techniques where the model is trained on labeled data. In this case, tumor data is labeled as either malignant. Supervised learning is effective because it uses historical data and make prediction about new cases. Model essential learners from the examples. There are other types of machine learning like unsupervised learning, whether the data is not labeled and the model trained find to the patterns on its own. This is the useful clustering or the anomalous detections but wasn't relevant for our specific task. Another method is in reinforcement learning, where the model learns by interacting with its environment and receiving feedbacks. But this is the more applicable to decisions making process than medical designation. The type of machine learning algorithm is the regressions and classification. In the regression part, there is a three types: learner regressions, support vector regressions, and Poisson regressions. In the classification, there's a four parts: the logistic regressions, neural networks, decision trees, and Naive-Bayes classifier. In this, and the next part will be introduced by the Paras Patel.
Hi, my name is Paras Patel. Thank you, James. Uh, you can see in this slide that there are types of machine learning algorithms. There are three types of machine learning algorithms: supervised learning, which use label data; unsupervised learning, which find the patterns without the labels; and the reinforcement learning, which of the learning optical action through the trial and error. In our project, we discussed supervised learning because of our dataset was labeled as either magnetic medical imaging techniques such as ultrasound providing the critical data for breast cancer detection. You can see in a different image they are showing the ultrasound cancer detection machines which are shown in figure 2. Moving on to the next slide, machine learning in a medical imaging. You can see here there are various type of data set that we have been provided. In this data set is about machine learning has significantly load in a medical imaging. Techniques like augmented and the ultrasound provide the data crucial for the breast cancer detection. Convolutional neural networks (CNNs) are partly be effective in analyzing image data. They are detected several features imagining they may be indicative malignancy. You can see as ID unique identifier for each pattern, diagnosis classification M, magnetic B for radius means texture and means. Now moving on to the next slide, dataset and descriptions. We used a dataset that includes information about breast cancer tumors containing 32 features exactly for the cell nuclei in digitized image of the fine needles aspiration FNA for the breast mass. Each tumor in a dataset is labeled either as the Bilikmini features including the properties such as radius, text, and smoothness of a tumor. You can see for the initial analysis, feature selection, and the pre-processing, we normalize the continuous variable for a model consistency, split the data into the 80% of a training and 20% of a test set. Feature engineering, no additional features we are creating as the dataset already consists rich descriptive variables. Moving on to the next slide, algorithm and model overview include testing. We implemented our 4 machine learning algorithms to classify breast cancer. First is decision tree, random forest, Naive-Bayes. Our initial analysis showed as a balanced number of illegitimate and being cases. There are no missing data which simplified our processing. We focused on our features such as radius mean and concavity worse. 3 features showed significant difference. These features show significantly difference between illegitimate and tumors, which help us in classifying them. I can show the decision trees are a simplified yet effective model that builds a tree based on a feature's importance, achieved decent accuracy but prone to overfit. Random forest, an ensemble method that improves the performance by building the multiple trees and arranging them precipitation. reduced variation, and improved overall performance. Navy Bayes, a probabilistic model that assumes the difference between the features, works well for the high-dimensional data like these datasets. Moving on to next.
Thank you, Paris. This is Abdullah Faryad, and I will explain about the algorithm overview decision tree and the algorithm and model overview, including tests. So first of all, it's like multi-layer perception, artificial neural network, and here we have to do is the deep learning based approach with multiple layers to capture complex relationships between features, and that showed the best performance among all models. And here we see like the algorithm where we have explained different linear regression, logistic regression, LSTM decision trees, random forest, and then reinforcement learning, then k-means clustering, KNN, ANN, and Navi base. And here in the next, the model performance evolution. First of all, we are taking the decision tree, and that was this is simple and effective model that builds a tree based on feature importance, while it provided the decent accuracy that was prone to overlifting, meaning it performed well on the training data, but not as well as on unseen data. As you see, the accuracy is 94.74%, precision is 93.02%, and the recall is 93.02%, and the F1 score is 93.02%. That for the for zero, we have the precision for 0.96 and 0.96 recall and 0.96 FI score and 71 score. And for the one, we have the precision 0.93 and recall and FI fun score is 0.93 as well, and the score is 43. So now in the next slide, for the random forest, and here we see like we use the random forest, which is an ensemble method, and usually it improves the performance by building multiple decision trees and then averaging their predictions, uh, and this reduced the variance and improved the overall accuracy of our model. If you see, the accuracy here is 96.49%, and the precision is 97.56%, and recall is 93.02%, and the F1 score is 95.24%. And the for zero, it's a precision 0.96, and recall is 0.99, and F1 score is 0.97, and score is 71. For the one is precision is 0.98, recall is 0.93, F1 score is 0.95, and the final score is 43. So now we are moving to the next slide, where we will talk about the Navi-Bayes. Uh, as we all know that Navi-Bayes model is a probabilistic classifier that assumes independence between the features, and it works well for high dimensional, especially the data sets like the one we have used. And despite as we know, it's a simple, and despite its simplicity, this model achieved a strong performance in our test. Here like we see, its accuracy is 96.49%, and precision is 97.56%, and the recall is 93.02%, and the final F1 score is 95.24%. So for the zero, we have the precision 0.96, recall 0.99, F1 score 0.97, score 71. For one, we have the precision is 0.98 and recall 0.93, F1 scores same as 0.95, and the score is 43. So in this slide, I will be talking about the multi-layer perception ANN, and this is the final algorithm that we have tested, and which is a type of deep learning model with multiple layers. This algorithm was the most effective as it captured complex relationships between features, leading to the best performance among all the models. Here we see the accuracy is 97.37%, precision is 97.62%, recall is 95.35%, and the F1 score is 96.47%. And we see this precision, recall, F1 score, and the support as the same as before. Uh, Here we will talk about the conclusions that we have achieved about our tests. So here, machine learning algorithms can effectively classify the breast cancer tumors with high accuracy, especially the multi-layer perception model, which has achieved the highest testing accuracy of 97.36, and uh, this makes it the most promising model for breast cancer detection. And our project demonstrates the potential of machine learning in assisting medical professionals with early cancer detection. For future work, we could expand the data set or integrate more advanced deep learning techniques to further enhance our accuracy. So that's it from my side. Thank you so much.